Evaluate root 5 plus root 7 times root 5 minus root 7. This looks very similar to something we've done before. When we had a binomial times a binomial, we FOILed everything out to figure out what the product was. And in a situation like this, we're going to end up doing the same thing. We're going to multiply the first terms, the outer terms, the inner terms, and the last terms. Let's get doing it. The first terms in each of these are root 5 and root 5. Root 5 times root 5 is root 25, but the square root of 25 is just 5. You can skip this step entirely, writing the square root of 25, and you can just say that root 5 times root 5 is 5. Remember, anytime we have the square root of a number times itself, we are squaring it, and what that effectively does is it gets rid of the square root. So that's the product of the first terms. Let's look at the outer terms. We've got root 5 times negative root 7. That's going to be negative root 35, because 5 times 7 is 35. Now we've got the product of the inner terms. Root 7 times root 5 is positive root 35. And then the product of the last terms, we've got a positive times a negative, so it's going to be minus. And root 7 times root 7 is root 49. But we know the square root of 49 is just 7. So that term is going to be minus 7. So we've got 5 minus root 35 plus root 35 minus 7. And if we combine the radicals, negative root 35 plus root 35 is 0. Those cancel out. And so all we have left is 5 minus 7, and 5 minus 7 is negative 2. So that whole crazy product ends up being negative 2 in the long run. And that's our final answer. There is actually a neat trick that we can use in a problem where we have something in this form. Whenever we have the sum of two terms times the difference of those same two terms, we actually have a formula for this. This is the first term squared minus the last term squared. This is actually how we got the formula for the difference of squares. So if we ever have a situation where we have a sum of two terms times a difference of those same two terms, instead of going through and FOILing it out, we can square the first term and then minus the square of the last term. So in this problem, where we have root 5 plus root 7 times root 5 minus root 7, we have this exact form. We've got a sum of two terms times the difference of those same two terms. So what we can do is we can take the first term and square it. The square root of 5 squared is actually 5. And then minus the last term squared, and the square root of 7 squared is just 7. So we end up with 5 minus 7, which is negative 2. It's the same answer, but we can do it without FOILing everything out. So those special products that we learned before can be really useful if we remember them and we're able to apply them properly. But just be careful, this only works if we've got the sum of two terms times the difference of those same two terms. If this was root 7 and this was root 8 or root 9 or something else, it wouldn't work out.